Welcome back, everybody. In this lesson, we are going to be actually practicing putting some things on a graph, and then we're going to deal with dependent and independent variables. We're going to work a table. We're going to figure out what a table has to do with graphing coordinate pairs. And then lastly, we'll work a word problem together. Now, I already did letters A through F over here on this coordinate plane. Let's go through how I got the answers that I got. So the instructions are to graph each ordered pair on the coordinate plane and label each point, and that's what I did. So first, I have this one, 0, 5. The first number in a coordinate pair is where you go on the x-axis. If it's a positive number, you go to the right on the x. If it's a negative number, you go left on the x. And if it's 0, you stay right in the middle, so you're right on the where the y-axis crosses. So this is 0. I don't move left or right at all, and I go up 5. The second number is how far you go up or down. If it's positive, you go up. 1, 2, 3, 4, 5. This is the point 0, 5. Letter B, negative 1. Oh, I have to go to the left one. Negative 6 is down 6. 1, 2, 3, 4, 5, 6. Negative 1, negative 6. Negative 2, 0, I go 2 to the left, but then I don't go up or down on the y-axis because it's 0. There's no vertical distance. So I'm just going to leave that one right here at negative 2 on the x-axis. I'm not moving up or down on the y-axis. Negative 3, 4. 1, 2, 3 to the left. 1, 2, 3, 4 up. Now, are you catching the pattern? I'm going horizontally first to the left or right, and then vertically for the second coordinate, up or down. Let's take a look and see if that continues. 5 to the right. 1, 2, 3, 4, 5. Down 1. 5, negative 1. And then F is 2, 1, 2, negative 4. 1, 2, 3, 4. 2, negative 4. All right, that's how you do those ones. Those are the easy ones. You just need to make sure you have graph paper and you are thinking through horizontal and then vertical. All right, next, for each pair of variables, identify the independent variable and dependent variable. Let's do that together. So for letter G, the amount paid and the number of toys purchased. Well, I'm in control of the amount that I spend. So the amount paid is the independent variable. And then the number of toys that I get for my money depends on their price. So the number of toys purchased would be my dependent variable. Now, hey, actually, now that I'm thinking this through, I might have done this backwards, and this is instructive. Sometimes you can interpret these more than one way, okay? So if I am going to pay an amount and just like buy the same toy, but I'm not sure how many I'm going to be able to afford for the amount that I pay, this could be correct. However, I think what they're going for here is I choose how many toys I purchase, okay? So this is going to be the independent. I'm not going to just pay a sum of money. I'm going to choose a certain number of toys, and then my amount paid would be my dependent variable, because that's how much. Maybe instead of the amount paid, the amount billed would be a better answer, because paid makes it sound like I'm doing it. Billed makes it sound more like it's the result of the number of toys purchased. So here's the thing. G could kind of go either way. That's why a lot of times they're going to ask you to explain your answer when you do this. And sometimes I can give you credit for one that's not what the book answer is because you explain and you're correct. All right, let's take a look at the next one. This one, there is no doubt. The number of hours worked, the number of yards mowed. I don't know, maybe there is a little doubt now that I think about it. The number of yards mowed is my choice, okay? So I'm going to say that the number of yards mowed, I'm going to choose to mow 5 yards today, 10 yards today, okay? I'm going to say that that's independent. And then however many yards I choose to mow, my number of hours is going to go up. The number of hours worked is going to be dependent. Now, you can make an argument the other way, too. You could say if I work 20 hours, I'm going to get so many yards mowed. I'm going to probably get 20 yards mowed. So, and if I only work 15 hours, I'm only going to get 15 yards mowed. Okay, so it could go either way on that one as well. That's why a lot of times they're going to ask for explanations. Now, letter I is an important one. What we're going to be doing here is completing the table for the equation y equals 2x minus 1. One of the ways that we graph equations is we fill in a table with several points, and then we put those points, turn them into coordinates on a coordinate plane. All we have to do here, though, is complete the table. So we're not putting anything on a coordinate plane in this one. What I need to do is figure out what value goes below -3. Okay, so I'm going to write -3, and then below -3, what number am I going to put? Well, let's see. If I plug -3 in for x, that's all I'm doing. Whatever this value for x is, I'm plugging it into my equation. 2 times -3 is -6, minus 1 is -7. So I would fill in -7 for y right here. What happens when I plug in -2 for x? 2 times -2 is -4, minus 1. That means that if I have, and let's see, I'm just going to do the same sort of thing. We'll separate with a comma. Let's do this. I'm going to put a comma there and a semicolon there. -2, comma, -5. When I plug in -2 here, I get -5. What about -1? -1, comma, what do I get out when I plug in -1 for x? 2 times -1 is -2, minus 1 is -3. You should notice that there's a pattern developing. Hey, here's the other thing you should notice. Do you notice that I can make each of these an x, y, because look at what the x's are, look at what the y's are. I can make each of these an x, y coordinate pair and graph them. And if I do that and I connect the graph to, I can graph this equation. We're going to be worried about graphing equations later, but this is just kind of getting you ready for it as we fill in some table values. Plug in x to get that particular y. This is the y that corresponds to -3. This is y that corresponds to -2 plugged in for x. This is the y that corresponds to -1 plugged in for x. All right, and the last one. The prom committee raises money for prom by selling flowers. The money earned for the prom is dependent on the number of flowers sold. Money is earned represented by the equation y equals 3x minus 75. Find the amount of money raised when 25, 50, 75, and 100 flowers are sold. So what I'm going to do is plug in these values for x and see what I get for y. So I'm going to write these as coordinate pairs. If I plug in 25 for x, what do I get out for y? 3 times 25 is 75, minus 75 is 0. So if I plug in 25, I get 0 out. 25, 0 is a point on my graph. What if I plug in 50? 3 times 50 is 150, minus 75 is 75. I make $75. Okay? What if I plug in 75? I'll plug in 75. 3 times 75 is 225, minus 75 is 150. So if I plug in 75, I make $150. Now, let's just think about this for a second. The first number I'm plugging in is the number of flowers sold. The second number is the amount of money I make. Do you see a pattern here? If I sell twice as many flowers here, I make $75. I shouldn't say twice as many. I sell 25 more flowers, I make $75. I sell 25 more flowers, I make $75. Let's see, $75 more dollars. Actually, this time I make $150, which is 75 more than 75. If I sell 100 flowers, all right, sell 100 flowers, I'm just going to write the labels on this one. How much money am I going to make? 3 times 100 is 300, minus 75 is $225. Okay? I could, by the way, write labels in each of these coordinate pairs just so we know what we're talking about. Or I could graph these and make sure that my graphs are labeled. So along the x-axis is the number of flowers, and along the y-axis is the amount of money I make. One more thing. How do you know that x-axis is flowers and y-axis is money? Well, how does a coordinate pair work? X is the first number. Y is the second number. And that's how we do it. All right, so for next time, you're going to have some of these sorts of problems. Things are going to start to get a little bit hard. I think these sorts of problems, they can be easy if you've done it before, but pay attention. Make sure you know what you're doing and you do things correctly.